we now want to look at some problems where we're given a polar coordinate and we're asked to convert it into a rectangular coordinate. Now on the formula sheet, these are pretty straightforward, but if you still want to refer to them, you can look at these right here. These are very straightforward problems because all I'm going to do is use this x equals r cosine theta and y equals r sine theta. I'm going from polar to rectangular, very straightforward. Matter of fact, I'll write them over here just to have them handy. So there's not a whole lot to these. So x equals, okay, I haven't given you a problem yet. So the problem is 6 is my radius, or r, pi over, 6 pi over 2. And what is it in rectangular coordinates? Now you could go ahead and use these formulas. Although some of you, when you look at this, and here's what I always say to do. I always say plot the point, right? Let's just do that so even I don't forget. It's like a sanity check, make sure you're not making mistakes. So pi over 2 is straight up. If you want to go 6, you can say this is 6. This is pi over 2. Now, it's sort of crazy to use these formulas when something like this is just common sense, right? Especially this is on like the y-axis. Isn't it pretty obvious? It's just going to be 0, 6. So that's why it's also good to plot these points, because sometimes when you plot the points, you realize you don't even have to do any math, that it's just very simple. Here's another one. So the polar coordinate is, now if you were not told, you wouldn't necessarily know this is a polar coordinate, but actually r is this and the angle is 0. And now they want to know what would that be in rectangular coordinates. Well, once again, if I go plot this point, so the angle 0 is right here along the positive x-axis, and I go a distance -2, which means I have to go the opposite direction. So maybe I'll draw it like this, where this distance is 2. So once again, I don't need to go use these equations here. I just need to write this point in rectangular coordinates. The distance is 2, but this point is like -2, 0. Right? X is -2, y is 0. All right, let's do one. Now this one, actually we're going to have to do a little bit of math, but it's not hard. So this one is 9, 2 pi over 3. So if we know this is a special angle, 2 pi over 3 is right here. And it's 9, so we'll just say this distance is 9. So now, what is this going to be in rectangular coordinates? Now we actually will need to use our equations up here. X equals r cosine theta. X equals r times the cosine of 2 pi over 3. Now they want exact values here. This is a special angle. If you look at your unit circle, cosine of 2 pi over 3 is negative 1/2. So the value of x is negative 9/2. Y is r sine theta. So r is 9 times the sine of 2 pi over 3. So these are just like plug and chug. You got these two formulas and you just simply plug this stuff in. 2 over 3 is a special angle. The sine of 2 over 3 is square root of 3 over 2. So you have 9 square root of 3 over 2. So in rectangular coordinates, this point is negative 9/2. It looks right because, you know, obviously x is going to be negative and y is positive. I don't have my calculator. We could do this calculation. So this is like negative 4.5. So you can see this as being maybe negative 4.5 in this value. So there's the answer. Not very hard. Maybe I'll do one more because these problems are just the plug and chug. So once again, going from polar coordinates to rectangular, use these two formulas if you need to, and you're on your merry way. Let's just do one more. This one looks messier. I don't think it's going to be hard. So here's the polar coordinate. Negative 3, and we need to determine what would that be in rectangular coordinates. So let's go ahead and plot this point first. Little tricky, both these are negative. Here's what I like to do. Since I know the unit circle has all positive angles, to show you, I'm going to go find the angle 11 pi over 6. 11 pi over 6 is here. So basically, a positive 11 pi over 6, you're going almost all the way around, but you're stopping at the very last special angle. So if I have negative 11 pi over 6, I'm going to go clockwise. And I'm going to stop here at the same place as pi over 6. So this is negative 11 pi over 6, or it's really pi over 6. And now, however, my r is minus 3, so it's going to go the other direction. So this is really my point here. So let's just define this using the unit circle. So I'll do a positive angle. Hopefully you can see if this is pi over 6, then this distance is also pi over 6. So when you start here, that angle is 7 pi over 6. So this polar coordinate I could rewrite as 3, 7 pi over 6. And I do that because I already want this angle to be on my unit circle. So these are actually the same point. So now, if I want to get x, r times cosine of theta, 3 times cosine of 7 pi over 6, which is 3. If you go to unit circle, cosine of 7 pi over 6 is negative square root of 3 over 2. So negative 3 square root of 3 over 2 would be x. And then y is r times sine of theta, which would be 3 times the sine of 7 pi over 6. 3 times 7 pi over 6 is actually, the sine of 7 pi over 6 is actually negative 1/2. So the x and the y, here's x, negative 3 square root of 3 over 2, and here's y. So that one is a little messier, but hopefully you can see it's definitely not difficult. The only tricky thing is I took the original polar coordinate and I sort of rewrote it, especially so that I can use my unit circle and call it 7 pi over 6. All right, I don't think those are going to be too difficult for you.